Hello, everybody. In this module, I would like to introduce you to environmental geology. One of the things that we're going to be talking about in this course is about natural hazards, and this is what you are looking at right now on the very first slide of this module. As you can see, here is the aftermath of Hurricane Sandy that New Jersey experienced at about, in 2012, which is more than 10 years ago now. But anyway, the very first thing that I would like to introduce you to is the definition of environmental geology. And for those of you who like to see the definition, this is what it is. Environmental geology is the scientific study of the interactions between humans and environment. As you can see here, this picture right here on the right side of your on your screen, this is a river in Colorado where it actually this is not a Photoshop. This is actually a real thing right here. The color of the water in the river looks yellow because it has some contaminant within the river. And this is one of the things that environmental geologists is working on how to get rid of the contaminants within public water, for example, in this case, a river in Colorado. Environmental geology, when we learn about environmental geology, it's all about how people and earth interact, or how people influence the environment, or how the earth impacts human activities. Okay, so basically it's an interaction between human and the earth or the environment, and there are several factors that we need to consider when we talk about or when we learn about environmental geology. The very first one is the human population, is how many people that we have in a certain region. For example, here is a picture of a market, I believe. I'm not really sure where that is exactly, but as you can see here, it is full of people. There's a lot of activities here. That is going on, and there could be some impacts to the environment because of these activities. Okay, and the second one is the resource consumption, how much resources that human consumes and how it impacts the environment. And then last but not least, again, how the earth's impact, or how the earth or the environment influence people's or human activities. Okay, more than half of Earth's inhabitants now live in cities. This is something that you just need to keep in mind. There are a lot of people live in cities, and if you like to read a book, I would definitely suggest this book right here, Green Metropolis, from David Owen. Why living smaller, living closer, and driving less are the keys to sustainability, according to David Owen in 2009. Some of the theses that he discussed in this book include cities are greener than suburbs. The reason for that is because a larger percentage of populations in cities, for example, in Manhattan, for example, people like to walk. People like to bike and use mass transit instead of driving. Even though you still see lots of cars in Manhattan, but it seems like most of them are do not live in the city itself. But another thesis that he discusses about the shared infrastructures that cities have built and live in smaller spaces with smaller energy demands for heating and cooling, meaning that we can save some energy instead of living in a big houses that utilize lots of energy, and there's no sprawl and less commuting if you live in a city where you also work. Okay. This is the chart of human populations, the growth of human populations since 1800s all the way to 2100s, as you can imagine right here. In 1974, I'm sorry. So in 2020, we have 7.8 billion people who live on Earth, and not really sure. I should have double checked on this before I record this video, but I think you should be able to find, the current this year's populations. I'm pretty sure right now I'm recording this video in 2023, so I'm pretty sure that we almost reached maybe 8 billions already this year. I'm pretty sure that this number has changed. But anyway, something that I would like to point out that is that in 1830 to 1930, for example, the world population actually doubled from 1 to 2 billion people. So here is 1830 something, somewhere around that area right there, to 1930 right here. So we have 1 billion to 2 billion by 1930, and then from 1930 it actually grows exponentially all the way to 4 billion in 1974. All right, and then it becomes steady, and then 7.8 billion eventually in 2020. And as I mentioned earlier, I'm pretty sure this year's population has reached almost 8 billion, or maybe more. The reason why we discuss this is because, of course, if you have more people in a certain region, especially on Earth, that means that we would need more natural resources such as soil, water, energy to support our activities on Earth. Okay, and that also means that could also give some negative impacts to the environment because of additional waste that will be produced by greater population. And another thing, another aspect of environmental geology is about consumption variation. This is also something that we need to consider. What that means is that, for example, here are two families that live in a very, very different regions of the world. I'm pretty sure this family here on the left side is from somewhere in South Asia. And on the right side, on the right picture right here, I'm pretty sure this family lives somewhere in maybe Europe or something like that, if you see the architecture behind them. But anyway, my point here, the reason why I would like to show you this is because it actually shows a contrast between how families who live in different regions would have a different consumption rate, okay, or different consumption pattern. So, for example, here is positions of family in rural India and suburban England. It varies a lot, as you can see here on the left side. We have 1, 2, 3, 4, 5, 6 people who live in this house right here, and this is all what they need in order to support their daily activities. As you can see here, there could be some rice maybe, these bags right there. There are some, pots and everything in order to cook. There's a bike for transportation. There's looks like a very comfy chair or whatever that is, in front of their house. And then on the right side, as you can see here, we have 1, 2, 3, 4 people, only 4 people. But look at how many stuff that they own. Look at this. They have not just one bike, they have multiple bikes, as you can see here. But not only that, they also have cars. 2 cars at least for these 4 people family. And then they have a bunch of sofa right there, a bunch of things, a bunch of stuffs. They have these machines right here in order to wash their clothes maybe, and they consume these things right here, right in front of them. But anyway, this kind of shows you how people who live in different regions would have different consumption pattern, and this could also give some impact to the environment. Okay. So that was just a very short introduction of environmental geology, and the next several slides, what I would like to give you is maybe just several reasons why people need to learn about environmental geology. Okay, the very first reason is obviously about the natural resources and sustainable development. Okay, um, when we say natural resources, this would include every single thing that human uh, exploits from the earth. Okay, so for example, I think this picture gives you a very good summary right here. This is a house right there, and within a household like this, there's a lot of things that have been created or have been produced from Earth's materials. For example, well, maybe I'll just start with this toilet paper, for example, right? So this is a toilet paper. Toilet paper is coming from a paper mill, and paper mill uses raw materials from trees. Okay, and the same materials can go into a lumber, and then they will produce lots of, maybe 3x4, all the woods, the wooden materials that are needed in order to build this house. Okay. But of course, not only that, we have, I'm pretty sure, most of you drive a car maybe, or even, or at least own a car, and then this is a car right there. In order to mobilize the car, in order to drive the car, we need gasoline. Well, unless you have a electric vehicle, right? But anyway, most of the vehicles nowadays still requires gasoline, and then that gasoline is coming from fossil fuel that has been mined or that has been exploited from the earth. And the same product right here that can go into power plant that would generate your electricity, and that electricity is used daily by every single of us, obviously, right? Because right now you're looking at a monitor, watching this video using an electricity, and that electricity is generated from a power plant that has been fueled by fossil fuels. Okay, so but not only that, as you can see here, water is another one. Metal ore. Oh my God, look at around you. Every single electric component has that, I don't know, maybe copper wire. Okay, these copper wire is coming from a copper resources that has been mined from the earth. So natural resources really, really support our daily activities, as shown by this picture right here. But what is this? What does this word mean? Sustainable development, or what does sustainability means? So sustainability, it means that it is a capability of being continued with minimal long-term effect on environment. Okay, so even though we need those resources that I've already shown you before, but we need to use it without, or we need to use it while minimizing the long-term effect on the environment. And that's what it means by sustainability. Okay, meeting the needs of the present without compromising the ability of future generations to meet their own needs. Okay, that's what it means by sustainability. Now, there are, of course, some problems with achieving sustainability. So, for example, leaving resources like fish, maybe forests, or those, trees, they are being used faster that they can be naturally replenished, and this would cause some problems. Okay, not only that, minerals. So, copper, for example, right, or lithium. Okay, lithium is an element that we use for our batteries, all right, for your phone batteries, for your laptop batteries. They all use lithium. And oil, groundwater. These are natural resources that are being extracted without concerns of their limits in some places of the world. Okay, so when these things happen, this could cause some problems with achieving sustainability. Okay, that means we're going to give more burden into the next generations, and we don't want that. Okay, so here is, well, just a pretty picture of a Bingham Canyon copper mine in Utah. This is one of the largest man-made hole of the world, and I think we're going to be talking about that later on. But anyway, um, when we talk about natural resources, we would also talk about energy resources, right? And energy resources is something that we're going to be talking about, I think, on the second or third unit of this course. This picture here on the left side shows you shale gas basins in the United States. These are the red areas that you see on this map right here represents an area that would produce gas. Okay. A new source of energy. Shale gas is a new source of energy in the United States, and it has about 500 to 1,000 trillion cubic feet. Okay, now if you cannot, if you're having a hard time imagining how much 500 to 1,000 TCF is, just imagine that 1 TCF, it can fill a 30 by 30 foot corridor, okay, and it can stretch around the earth 3 times like this. 1, 2, 3, okay, 30 by 30 feet corridor. Okay, so that's how much 1 TCF is, and we're talking about 500 to 1,000 TCF that the United States has from shale gas only. Okay. However, these types of natural resources requires a special method in order to extract these gas from from the ground. Okay, and this special method is called hydraulic fracturing, or people would just call it fracking. Okay, these are a method in order to generate artificial fractures within the rocks at depth. Okay, what basically is done is that people, in order to frack, in order to get the gas from the ground, we need to create artificial fractures, and the way they do it is they pump a lot of water from the surface all the way to this rock formation at depth right here, until this rock formation break and it releases it gas towards the surface. Okay, and that is what we call as hydraulic fracturing. Of course, the process is much more complicated than what I just said, but I'm pretty sure you have heard about, hopefully you've heard about these terms before, because this is one of the topics that has been discussed a lot in the media, because it draws a lot of debate over whether fracking is good or bad for environment. Okay, so for example, here is a news from CNN right there. Leave our communities, the frack alone. All right, there you go. Natural resources, or especially energy resources, especially oil and gas industry, has been highlighted by mainstream medias. The reason for that is because, of course, in history there has been multiple incidents associated with the activity of exploration and exploitation of hydrocarbon or oil and gas from the earth. For example, here is one of the incidents, Deepwater Horizon rig incidents in the Gulf of Mexico that occurred in April 2010. This is definitely one of the worst incidents in the oil and gas in the recent history. Okay. And here is a picture that shows, again, a different consumption patterns. For example, here is on the right side, here we have the United States. And then if you compare to Bangladesh and Ghana on the left side of the chart, I mean, United States use much more energy compared to some of the countries in the world. Okay, so average citizens of the United States uses about 20 times as much energy in a year as citizens of Ghana, and 46 times as much energy as citizens of Bangladesh, as shown by this picture right here. So again, the consumption patterns of different countries is another important factor to consider when we learn about sustainability and natural resources in environmental geology. Okay, now the implications of sustainability, meaning that, because we need definitely, right now we need to support ourselves, we need those energy. Okay, but how can we use this energy without giving more burden into the next generations? Okay, now that is a big issue actually. So the implication is that we need to increase energy demands. The increasing energy demands dictate alternatives to burning limited reserves of fossil fuels. Because right now, most of the electricity has been generated from burning fossil fuels, and as we will learn later in this course, that there's a problem of burning fossil fuels here. Okay, especially the impacts to the environment is kind of huge actually. So we need to think about the alternatives of energy resources. So for example, here is one of the alternative of energy resources. This here on the left side of your screen, you are seeing a nuclear power plant in New Jersey. And this is just one of them that we have in New Jersey. Okay, so if you think that we don't have any nuclear power plant here in New Jersey, you are incorrect. Okay, because there are actually multiple of nuclear power plants in and around New Jersey, and this is New Jersey's offshore wind farms. This is a big, big thing. If you follow the recent news, this is definitely one of the biggest projects that New Jersey is currently pursuing in order to build offshore wind farms offshore New Jersey. And if you go to the beaches, of New Jersey, if you go to the Jersey Shore, for example, I recently went to Wildwoods, New Jersey. There's a lot of signs, about these issues. Okay, but again, this kind of shows how that there are people who are thinking about alternative energy resources, okay, in order to again reach that sustainability that we discussed earlier. Okay, the global sustainability, it actually includes these economy. There are three factors that would impact global sustainability: the economy, the environment, and the society. And in this course, we're going to be talking more about the environment. Okay. 1/3 of world's cropland abandoned during past 40 years due to erosions. There's lots of deforestations, and problems with water has also been increasing, especially in developing countries. Okay, now these are all the problems that are associated or that could prevent, global sustainability. Okay, and the reason why I have to mention that is because I would like to introduce you to the concept of carrying capacity. Again, this is the definition of carrying capacity. It is the number of people that the Earth can support. Okay, at a defined level of economic and social well-being. Okay, again, those are the three factors: the Earth, that represents the environment. The economic is, of course, represent the economy as well as the society. Okay, again, those are the three main factors that could affect the carrying capacity. Okay, now why is it so important? We have seen an example of carrying capacity overload, for example, in Easter Island, offshore Western Chile, right here in the South Pacific Ocean. Okay, this is the the general area of Eastern Islands. This island used to be, lush, and there's a lot of greeneries, trees and vegetations, but deforestation that occurred in this eastern island in this island unfortunately made resources unavailable, and the society become unsustainable. Okay, and we don't want that. This is just a little example of carrying capacity overload that occurred in a small island in the Pacific Ocean, but we do not want this to happen in a bigger scale. Okay, and we need to prevent that to happen in a bigger scale as well. All right, the second reason why we need to study environmental geology is because of natural hazards. I think I mentioned that earlier, that natural hazards is one of the topics that we're going to be talking about in this course, and many earth processes are hazardous to people. Okay? Tsunami hazard zone, for example. I'm pretty sure this one is. I don't know where exactly this one, but I'm pretty sure this one is from the western part of the United States, or maybe Canada. So there are several things that environmental geologists do. One of the big thing is about the mitigation of natural hazards. Okay, what they do is they identify of potential natural hazards, and then they create a design. They design, plans and efforts to minimize the risk and potential casualties and damages associated with natural hazards. And there's a lot of natural hazards, and each region typically has their own natural hazards. Okay, so for example, here in the eastern part of the United States, we don't have lots of earthquakes, for example, and there's a reason for that. Hopefully, you'll learn that through the next modules. Um, Here in the eastern part of the United States, we don't have lots of volcanic eruptions and earthquakes, right? But people who live in the western part of the United States, maybe in California, they are pretty much accustomed to earthquakes, actually, because they know they live in a regions where earthquakes often occur. Okay, and there should be people who think about how to mitigate or how to minimize the risk and potential damages and casualties associated with natural hazards. And this is one of the example of, again, one of the most devastating natural hazards in human history, Japan earthquake and tsunami that occurred in March 2011. Okay, and the next reason why we need to study environmental geology is to have a good land use planning and assessment of environmental impact. Okay, so for example, here's a picture of Fukushima nuclear power plant in Japan, and this power plant right here has been severely damaged by an earthquake that occurred in that region in Japan. So again, because we need those alternatives of energy resources, but we also have, at the same time, we also have to consider the areas. What about the geology of the areas? Would the geology affect or cause more or pose more risk of getting those alternative energy? So the big question here is that is Japan ideal to have nuclear power plants? Okay, and that would be something that you might be able to address after taking this course. Okay, this is another example of an illustration that when you would like to build a house, for example, you got to think about what is the history of this area. All right, has there been floods, major floods in the past? Okay, what is the chance of major floods in the past? Um, in this area. Okay, so for example, here we have 10% of annual chance, 10-year flood elevations. Okay, would be this, would be right at that elevation. So we would be pretty much safe if you had a house right there. It would also be safe from the 100-year flood. Okay, because the 100-year flood uh, is at this level right here, but this area is clearly not safe from the 500-year flood, okay, which have about 0.2% of chance to occur every single year. Okay, so again, flooding again is something that we're going to discuss in the future modules, but again, just to give you an illustration that this is something that we think about in environmental geology. Okay, the next one is about pollution and cleanup. Okay, we will talk about pollutants and contaminants, and why they occur in environment, and what are the efforts to clean up those contaminants or pollutants that we have on Earth. Okay, so this is just to give you again some examples of contaminants that occurred in Colorado. Again, this is the picture that you already saw before, and this is another picture of contaminated region in West Virginia. Okay, there's a polluted area over there. Now, this is not because recent activities that occurred in this region. Most of these cases are basically old cases. Okay, so maybe in the late 1800 or early 1900, where people discovered some mineral resources, and they do some mining activities over there. But at that time, there was no regulations uh, from the local government to regulate how these mining activities should be done. Okay, so what happened is that they just mine the natural resources from the ground without actually considering the negative impacts of that activity. So that actually you know cause or that actually just causes this environmental geologists that are nowadays need to basically think about how to get rid of these pollutants and contaminants from the environment. Okay, so basically most of these activities have been done in the past because of the lack of regulations in the past of mining activity in that region. So when we think about pollution, I think we have to talk about this person right here. This is a picture of Rachel Carson. She is she's basically the pioneer who actually talk about the negative impacts of pollutions in the environment. Okay, so she was the one who wrote this book right here, The Silent Spring. Okay, with introductions of Al Gore, the vice president at that time. Okay, she was mostly talking about the widespread use of pesticide. Okay, and she focused on the effects of DDT, which is the pesticide that was widely used at that time on bird shells. Okay. Silent Spring elicit public outcry for direct government action to protect nature. Okay, and then because of her effort, DDT eventually got banned in 1972. Okay, and because of that, because of her constant effort, she's considered as the mother of the American environmental movement. Okay. And not only that, her work led to the formation of some federal agencies. For example, the EPA, the Environmental Protection Agency of the United States, was created because of her effort. Okay, and then there's also some regulation that was produced because of her work. For example, there's a Clean Air Act of 1970. The legislation at the time authorized development of federal and state regulations to limit emissions from both industrial and mobile sources. Okay. Um, and it actually prevented over 200,000 deaths in 2020, and it costs a lot. Actually, it costs a lot of money. It's expensive to do this, but the benefit is even more. Okay, the benefits is estimated to be about $2 trillion compared to $65 billion. It's really nothing. Okay, and then the fifth, and I believe this will be the last reasons why we need to study environmental geology, is to understand the Earth's natural processes and changes. Um, I think for this picture, for this point right here, I'm just gonna show you some pretty pictures of natural processes that are occurring on Earth. So, for example, here is Pahoehoe lava. This is called the igneous processes, something that we're going to be talking about in the next modules. Um, this shows you how rocks form, or how lava turns into a solid rocks, and this would be called igneous rocks. And again, don't worry about those terms. We're going to be talking about those terms in future modules. And we're also going to be talking about processes, natural processes that occur in streams and rivers, for example, like here in this picture. And of course, we're going to be talking about some natural hazards as well. As I mentioned earlier, these are landslides that occurred in, I believe it's somewhere in Eastern Europe, I believe. But as you can see here, these land has failed, and everything just drops down in this region right here. Okay, so I think that will be it for this video. And if you have questions about anything that I talk about in this video, feel free to send me an email or ask questions in the forum. Okay, and I'll see you again in the next video. Bye bye now.